Hello and welcome back to another Duncan Codes. My name's Duncan and today we're continuing with our massive open online course from the University of Helsinki, and we are starting our journey on part 5. In this section we're going to be looking at learning object-oriented programming, removing repetitive code, primitive and reference variables, objects and references, and then a bit of a conclusion before we move on to part 6. So let's have a go and see what we're up to today. So we're going to revise the concepts of class and object to realise that a program that has been written without objects can also be written using objects, and to realise that the use of objects can make a program more understandable. So what's object-oriented programming all about? Let's step back for a moment and inspect how a clock works. The clock has 3 hands, hours, minutes and seconds. The second hand grows once every second, the minute hand every 60 seconds, and the hour hand every 60 minutes. When the value of the second hand is 60, its value is set to 0, and the value of the minute hand grows by 1. When the minute's hand value is 60, the value is set to 0, and the hour's hand's value grows by 1. When the hour hand's value is 24, it's set to 0. The time is always printed in the form hours, minutes and seconds, where 2 digits are used to represent the hour, so for example 1 to 12, as well as the minutes and seconds. The clock has been implemented below using integer variables. The printing could be in a separate method, but has not been done here. So what have we got here? So we've got 3 integers, all initialized to 0. While true, if hours is less than 10, system.out.print 0, so that's our hours, followed by system.out.print for hours, 1 for a colon. If minutes is less than 10, system.out.print 0, and then so on and so on. And then we've got our if statement here, which is going to update our logic and make sure that the correct digits are output to our console. As we can see by reading the example above, how a clock consisting of 3 int variables works is not clear to someone reading the code. But by looking at the code, it's difficult to see actually what's going on. A famous programmer once remarked, "Any fool can write code that a computer can understand. Good programmers write code that humans can understand." Our aim is to make the program more understandable. Since our clock hand is a clear concept in its own right, a good way to improve the program's clarity would be to turn it into a class. Let's create a clock hand class that describes a clock hand, which contains information about its value, the upper limit, the point at which the value of the hand returns to 0, and provides methods for advancing the hand, viewing its value, and also printing the value in string form. So we have got public class clock hand. We've got 2 instance variables up here. We have our constructor. We can tell it's the constructor because it's got the same name as the class and it's a capital first letter. It is passed 1 value, which is of type integer, and it is called limit. This dot limit is set to limit, so this value here is going to be updated with the value here. And then we've got this dot value, which is this one up here, is set to 0 initially. So we've got public void advance, so we're updating our value. If this value is greater than or equal to this dot limit, this dot value equals 0. And then what have we got here? So we're overriding the toString class here and printing out the 0. Once we've created our clock hand class, our clock has become clearer. It's now straightforward to print the clock. For example, the clock hand and the hand's progression is hidden away in the clock hand class. Since the hand returns to the beginning automatically with the help of the upper limit variable defined by the clock hand class, the way the hands work together is slightly different than in the implementation that used integers. That one looked at whether the value of the integer that represented the clock had been exceeded the upper limit, after which its value was set to 0 and the value of the integer representing the next clock hand was incremented. Using clock hand objects, the minute hand advances when the seconds value is 0, and the hour hand advances when the minute's hand value is 0. So let's see what we've got. So we have 3 objects created here. So we've got an hours object created from clock hand and it's passed the value of 24, a minutes object with a value of 60, and a seconds object also with a value of 60, and then while true we're running through this loop. So you can already see how much clearer the code is from this original code up here, just by separating out the bits of code that need to remain together is more relevant now to make this look a lot nicer to read. So let's see, we've got while true, system.out.print hours plus minutes plus seconds. We're advancing the seconds. If the seconds value is equal to 0, minutes.advance, so every time it goes round and resets to 0, 1 will be added to the minutes. And then inside that we've got a nested if loop, a nested if statement. If the minutes value is equal to 0, then the hours are advanced. Object-oriented programming is primarily about isolating concepts into their own entities, or in other words, creating abstractions. Despite the previous example, one might deem it pointless to create an object containing only a number, since the same could be directly done with an int variable. However, this is not always the case. Probably worth mentioning about abstractions. In computational thinking, there are 4 keystones to it, or milestones. Abstraction is one of them. Why has that only got 3? Oh, here we go. So decomposition, abstraction, algorithms, and pattern recognition. And basically these are all about removing or breaking down problems, removing the specifics, coming up with a general idea and being able to make reusable code. So decomposition is all about breaking down a bigger problem into smaller, more manageable pieces and dealing with each of those pieces and then bringing it back to fit together for the overall problem. Abstraction is about removing specific details to make problems a bit more generic so that you can spot patterns and reuse the code in that sort of pattern recognition way. And algorithms are all about creating sequences of events or sequences of code that can repeatedly perform a function. So computational thinking is definitely worth having a look at. There's loads of stuff on YouTube about it if you want to have a quick look at it. Realistically, you probably only need to watch maybe 5 or 10 minute video to get the basics, but there is a lot more behind it than that. There's a lady called Jeanette Wing, I believe she works for Microsoft, and she's a real big advocate and pusher of computational thinking. There's plenty that you can sort of deep dive into if you find it especially interesting. Right, so separating a concept into its own class is a good idea for many reasons. Firstly, certain details such as the rotation of a hand can be hidden inside the class or made abstract. Instead of typing an if statement and an assignment operation, it's good enough for one using the clock hand to call a clearly named method advance. The resulting clock hand may be used as building block for other programs as well. The class could be named counter limited from top. That is, a class created from a distinct concept can serve multiple purposes. Another massive advantage is that since the details of implementation of the clock are not visible to the user, they can be changed if desired. We realise that the clock contains 3 hands. It consists of 3 concepts. The clock is a concept in itself. As such, we can create a class for it too. Next, we create a class called clock that hides the hands inside of it. So we've got everything that we've seen so far. So we've got our instance variables, we've got our constructor, we've got the advanced methods and the toString as well, but it's all been encapsulated within this clock class. The way the program functions has become increasingly clearer. When you compare our program below to the original one that was made up of integers, you'll find that the program's readability is superior. I must admit that does read quite nicely, doesn't it? It's all sort of separated into its own methods or constructors. It's not sort of overloaded with loads of statements and sort of bits being pulled together. So it does look quite nice, and like they said above, you could use this for other functions as well, rather than just a clock. So here we've got clock equals new clock. So remember, this version of clock here is the object, and we're creating a new constructor, or we're using the constructor to create that new object. So while true, system.out.println clock, and then clock advance. So that'll just keep printing out and continuing until it's stopped. The clock we implemented above is an object whose functionality is based on simpler projects, i.e. its hands. This is precisely the great idea between object-oriented programming. A program is built from small, distinct objects that work together. So here's our first exercise. The exercise template comes with the clock hand class described above. Implement a timer class based on the materials clock class. The timer has 2 hands, one for hundredths of a second and one for seconds. As it progresses, the number of hundredths of a second grows by 1. When the hand corresponding to the hundredths of a second reaches the value of 100, its value is set to 0 and the number of seconds goes up by 1. In the same way, when the value of the hand corresponding to seconds reaches the value 60, its value is set to 0. So we've got public timer that creates a new timer, public toString, returns a string representation of the timer. The string representation should be in the form seconds, hundredths of a second. We've got that colon in there as well, where both the seconds and hundredths of a second are represented by 2 numbers. For example, 1983 would represent 19 seconds and 83 hundredths of a second. And public void advance moves the timer forward by a hundredth of a second. You can test out your timer's functionality in the main program whenever you like. The example code below provides you with a program where the timer is printed and it advances once every hundredths of a second. The program above will never stop running by itself. Press the red square to the left to turn it off. Grand. Okay, well, I don't think I've got NetBeans open. Let's get that open and let's see what projects we've got. So we've done sports statistics, let's close that. And here's our 1 minute program. So we've got clock hand, we've got program 2. Let's drag that to the left a bit, and we can move these side by side, can't we? So we can have our code displayed like that. Right then, let's get our new timer class created. There we go. Okay. So inside the timer class, we're going to need 2 instances of our clock hand class, aren't we? The constructor from there. Shall I just move that here? There we go. And they're going to be called second and hundredth of a second. So we'll create those as private, keep them encapsulated. So we're using the class here as our variable type. We're going to create a constructor, so public timer, and we're going to say this dot seconds is equal to a new clock hand, and the clock hand is expecting an integer, so we can see here, and because it's seconds it will be 60, and then we'll do this dot hundredths is equal to new clock hand again, but this one is going to be past past 100 because it's 100ths of a second. We're going to need an advance method, so public void advance, and then we can do this dot hundredths dot advance and then a semicolon, whoops, and then what we can say is if this dot hundredths dot value equals 0, this dot seconds advance. So when our hundredths gets to 0 to 100 and round again, we'll add 1 second. And then I think we need to put the public to string in, don't we? So we can do it automatically using alt and insert, but it's only a small to string. So let's just do it. And to be fair, it's more custom, isn't it, than the other one, because we need to put in the specific, what was it? Seconds, hundredths of the second, etc. So let's move that, put that back over here. So we are going to return seconds. That's going to be plus the colon like that, and then we're going to have hundredths, and that's going to be plus of a second like that. There we are. Okay, so now we've got our class sorted. We can use the while statement, or the while loop, from the University of Helsinki's example here to add in the while statement that we need. So we can say, so ours isn't called clock, ours is called timer. So I'm just going to close that so I've got a bit more screen space. So I'm going to say timer, oh actually what did we need to call ours? Implement timer, oh timer, that's fine. So timer equals new timer, and then we're going to say while true. So remember, this won't break out of the loop, will it, until we press the red square. So we've got system.out.println, and we're going to print out the value of timer, and then we are going to advance it, timer.advance, Then inside there we need to put our try catch. So try, and we're going to do thread.sleep 10. We're going to catch an exception. Just call it E, and then in there I'm just going to do e.getMessage, just in case we need it. Let's just have a look and see if that needs anything else. Okay, that should look good. Let's give it a run locally and see what it looks like. There we go. Yeah, it's quite cool. So we need to stop that running. Let's give that a run and see what we get back. Oh, we need to do our GitHub as well, don't we? Well, oh, it's failed. Spoke too soon. I guess it must be my format output. For example, 1983. Oh, because I put the of a second bit on the end, isn't it? Maybe. Let's go back and get... Where did I put that of a second bit? Oh, it was in the timer class, in the toString. So let's just get rid of this. Like that. Let's give that another run. Oh. Printing the result of toString of a newly created timer should result in... Oh, that's because I got a space. Can you see there? It's the 2 zeros are right next to the colon, but I put a space in. That's okay. So write small amounts of code and test often. That's fine. There we go. Awesome. Let's get our project location. Copy that, open bash if you're using bash, and then we're going to change directory, insert our folder location, press enter, then we're going to do git add, aren't we, to add all of the new code that we've just created to the commit or the message that we're going to create, and then we're going to do git commit -m completed part 5 exercise 1. Off to a great start, guys. Off to a great start. And then we just need to git push that up to git push u origin and master. There we go. Awesome. Oh, let's close that. There we go. Right, let's close that. Let's refresh this one. And now let's review the topic of terminology. An object refers to an independent entity that contains both data, instance variables, and behavior, methods. Objects may come in lots of different forms. Some may describe problem domain concepts. Others are used to coordinate the interaction that happens between objects. Objects interact with one another through method calls. These method calls are used to both request information from objects and give them instructions. Where are we? So an object refers to an independent entity. So entity is used as a database term as well, and you'll see if you have done databases at school or if you're coming up to do databases, you'll see that there's lots of familiar terminology that's shared between the two, and it can just give you a different context to understand programming or a different context to understand databases as well. So that is quite useful. Generally, each object has clearly defined boundaries and behaviors and is only aware of the objects that it needs to perform its task. In other words, the object hides its internal operations, providing access to its functionality through clearly defined methods. Moreover, the object is independent of any other object that it doesn't require to accomplish the task. In the previous section, we dealt with objects that represented people whose structure was defined in the person class. It's a good idea to remind ourselves of what a class does. A class contains the blueprint needed to create objects and also defines the object's variables and methods. An object is created on the basis of the class constructor. So we can see that in this example that we looked at. So when I was in the main program and said that this is the constructor that we're creating, so the constructor here is what we have created, and the clock hand one here, this is also making use of the constructor as well. So constructors are useful for kind of defining what the object should do initially, or what values it should hold initially as well. So if we think back to our person objects, they had a name, age, weight and height property along with a few methods. If we were to think about the structure of our person objects some more, we could surely come up with more variables related to a person, such as personal ID number, telephone number, address and eye colour. Realistically, we could add all sorts of information to that, and as we add more information, we'll probably find sort of subsets of classes that we could create and make our code more efficient. In reality, we can relay all kinds of different information and things to a person. However, when building an application that deals with people, the functionality and features related to a person are gathered based on the application's use case. For example, an application focused on personal health and well-being would probably keep track of the variables mentioned earlier, such as age, weight, height, and also provide the ability to calculate body mass index and a maximum heart rate. On the other hand, an application focused on communication could store people's email addresses and phone numbers, but it would have no need for information such as weight or height. The state of an object is the value of its internal variables at any given point in time. In the Java programming language, a person object keeps tracks of the name, age, weight and height and provides the ability to calculate body mass index and maximum heart rate, which would look like the following. Below, the height and weight are expressed as doubles. The unit of length is 1 meter. So this is what we've done if you were doing it before, followed along with this example. So we should have all of this already coded. Determining the maximum heart rate and body mass of a given person is straightforward using the person class above. So here we've got the user prompts, these inputs, we're creating our new person and then we're printing out the toString. So we've got BMI and then the body mass index and then maximum heart rate for the maximum heart rate as well. Napoleon had a very high BMI. There you go, who knew? A class defines the type of objects that can be created from it. It contains instance variables describing the object's data, a constructor or constructors used to create it, and methods that define its behaviour. Rectangle class is detailed below, which defines the functionality of a rectangle. So here we've got our rectangle class, we've got int width and height, we've got a constructor for a rectangle here, we've got a widen method, a narrow method, a surface area and toString. Some of the methods defined above do not return a value, methods that have the keyword void in their definition, while others do. Methods that specify the type of variable to be returned. So let's see, this one here, this is a void, so it doesn't have a return type. If it did, there would be a return keyword between this closed curly brace and this one here, just like this one, public string, so we're expecting a return type of string, and here on this one it's public int, so the width and height would be int variables that would be returned as well. So in an odd sense, void is a return type. The class above also defines the toString method, which returns the string used to print the object. Objects are created from the class through constructors by using the new command. Below we'll create two rectangles and print information related to them. So we're using their rectangle class here, which is making use of a new copy of the constructor. So if we go up, we can see the constructor takes two variables, int and height, and we're passing two variables, two integers here. And then again for the next rectangle, we've got 10 and 10, and then our printouts. Create a book class that describes a book. Each book has an author, title, and page count. Make the class a constructor, so that needs to take author, name, and pages. A get author, get name, and get pages. In addition, make a public string toString method for the book that will be used to print the book object. For example, the method call should produce the following output. Right, let us close this down and get the other one ready and raring to go. So we're doing book now. There we go, so we've got our program class. We're going to need to create a book class. Okay, so let's call this book. And we're going to need 3 instance variables. So we're going to need string author. We're going to need string name. And we're going to need int pages. we're going to need our constructor, so it will be public book. Remember, constructors always have the same name as the class. So we're going to say string author, string name, and int pages. There we are. Let's just minimize that. Close that. Just give ourselves a bit more screen space. So now we need to put in our assignments. So this dot author equals author. Ooh. This dot name equals name, and this dot pages equals pages. And we've been asked to include 3 methods. So we need a public string get author, get name, and get pages. So public string get author. So when they say get, they mean they're getting the data from these saved variables here. So as soon as we create this object, the data here will be updated with whatever we pass to it. So the get author will be able to retrieve the data that's stored there. So we'll do return author. Then we've got public string get name, and we can return name. And then the last one, remember we can use the keyboard shortcut as well for the getters and setters, and we can auto generate that too. There we go. So that's all we need in there. Oh no, it's not, is it? Because they've asked for the toString method as well. So let's add in our toString. So one of the toString is one that we can also add in automatically, like that. But obviously that's quite a lot different compared to what they've asked for. So I am going to delete most of this. There we are. So what are we going to return? We are going to return author, or get author, plus get name plus get pages. And I've just noticed in there that we've got some commas, so it would be get author plus comma, and here we need a plus comma as well. Let's go over here, let's uncomment this and see what happens. J.K. Rowling, Harry Potter and the Sorcerer's Stone, 223, and I just noticed on the end there that I forgot to put the word pages, so let's add that in. Plus pages, there's no full stop. So let's give that a run give that a run locally and see what happens. Excellent, there we go. Let's get that one sent off. Oh, let's do our GitHub. So git add to add our new file changes. Git commit, which is going to be our message, and we're going to say completed part 5 exercise 2, and then we're going to do a git push u origin master like that. There we go. Let's OK that. Give this a little refresh. There's our points. Actually, let's just have a quick look, because I think I looked the other day and I thought I was missing a point, but mustn't just have updated. It looks good. Create a cube class that represents a cube. Create a public cube int edge length constructor for the class. It takes the length of the cube's edge as a parameter. Make a public int volume method for the cube, which calculates and returns the cube's volume. The volume of the cube is calculated with the formula edge times length times edge times length times edge times length. Moreover, make a public string method for the cube, which returns a representation of it. The string representation should take the form of this. Well, L is the length and V is the volume. Both length and volume must be represented as integers. Okay, let's get cracking. So let's open the projects using Control and 1. Close this one, and now let's open Cube. and we're going to need to create a new class, and the class is called cube. There we are, and it only has one instance variable, which is int edge length, and we need a constructor which is going to be public cube, and that's going to be int edge length, like that, and we can say that this edge length is equal to edge length. And what else do we need? A public int volume. So because it's int rather than public void, it's going to need a return type of int. So we can return edge length. I'm fairly sure if we do times 3, let's have a look. Java cube so they've just done the ints times that, but I thought there was a shorthand way, but maybe there isn't. That's fine. Not a problem. Let's close that down then and do edge length times edge length times edge length. So I'm going to copy edge length. There we go. So you could do it slightly different if you want. You can add an extra line in for the workings out and things like that, but that seems like the quickest and easiest way. We need the toString method, don't we? So that one's going to be @override public string toString, and in there we're going to return, I'm going to copy this and I'm going to just update it with the bits that we need and the bits that we don't need. So let's just paste that in here. And we're going to replace this with edge length, and the volume, we can get rid of that and add in, was it volume? It was just called volume, wasn't it? Volume. There we go. There we are. Right, let's head back to our program and let's just copy this in. So Control A to select everything, and then Shift, Alt and F on your keyboard, and that will line it all up nicely. Let's see what happens. Passed. Excellent, that is great. Let's get that sent off. And let's update our GitHub too. So git add git commit completed part 5 exercise 3. Yeah. And then git push u. I think we should be able to do git push u, and that should do the job still without having to type in origin and master. So that's good. Alright. There we are. Right, let's have a scroll down. Gosh, we've only got that last one to do. So, Fitbyte. The Carvonian method allows you to calculate your heart rate for physical exercise. The target heart rate is calculated with the formula maximum heart rate minus resting heart rate times target heart rate percentage plus resting heart rate, where the target heart rate is given as a percentage of the maximum heart rate. For example, if a person has a maximum heart rate of 200, a resting heart rate of 50 and a target heart rate of 75 of the maximum heart rate, the target heart rate should be around 200 minus 50 times 0.75 plus 50, or 162.5 beats a minute. Create a class called Fitbyte. Its constructor takes both an age and resting heart rate. The exercise assistant should provide a method target heart rate. which is passed a number of type double as a parameter that represents the percentual portion of the maximum heart rate. The portion is given as a number between 0 and 1. Well, it sounds like a good one. Right, let's open up the correct package, or project, sorry. We're going to need to create a new class, and it was called Fitbyte. Oh, with a lowercase b. So that's not a problem, so just double click it, press Ctrl and R for rename, and then replace the b's there and refactor, and that will make sure it's all nicely updated. Right, so we've got that. We need public, no we don't, we need private int age. Let's think. We're gonna need this, but I'm just gonna remove it because I'm gonna work from top to bottom. I'm gonna add these variables in here, and then if we don't need them, which I imagine we will, we can remove them. But I'm gonna work through the project from top to bottom, adding in bits and pieces. Like I say, so we're gonna have a private int, which is maximum heart rate. We're gonna have resting heart rate. We are going to have target heart rate as a percentage. Target heart rate percent. We've already got resting heart rate, that's good. So we need an int for age as well, so int age. Let's see, the constructor takes both an age and a resting heart rate. We've got both of those. Okay, the exercise assistant should provide a method target heart rate, which is passed a number of type double as parameter that represents the percentual, and the proportion is given as a number between 0 and 1. Okay, that looks good. Oh, they've called theirs differently to me. So they've got percentage of maximum, and knowing how finicky they can be, I'm going to change mine to match theirs. Percentage of maximum. Okay, let's create the constructor then. So that's going to be public Fitbyte. It's going to take int age and int resting heart rate, and we're going to do this dot age equals age, and this dot resting heart rate equals resting heart rate. And then from there we need a method called public double target heart rate. So public double, so because it's of type double rather than void, it's going to expect a return type of double. So public heart rate, which is going to take double percentage of maximum. For now, I'm just going to return that just so it gets rid of the error. Right, so this is where I guess we need to put in the formula. So we should actually be able to return this all on one line. Right, let's actually move that up. So if we do maximum heart rate minus resting heart rate, so that needs to be wrapped in brackets, and that's going to be times target resting heart rate as a percentage, or percentage of maximum. Oops. Percentage of maximum plus resting heart rate. Right. So percentage of maximum doesn't have a value at this point, and it's not being used. So let's see. Okay. So I don't think we need this because we're passing it directly here. So let's just comment that out, and then we'll have a test and see what we get back on things. use the formula to calculate the heart rate. So if we do that, we should get this printout. So let's have a go at this and pop that in our, oh, it's here already, that's good. Let's do that. Oh. Oh, why is that not uncommenting? There we go. Okay, let's give it a run. I'm a bit apprehensive on this one. A bit pessimistic. Oh, I didn't put the toString class in. Did I? No, but it printed out anyway. Oh, because the printout's here. Okay, let's see what printout. Where are my printouts going? Let's add in the maximum heart rate bit. Maximum heart rate equals 206.3 minus 0.711 times age. Let's give that a run. Okay, so the last bit down here is just saying to delete variables that aren't used, which is fine. So let's get rid of these. So we need to get rid of those two. Sorry, that one. And this one. Let's give that a run again. And we're passed. Excellent. Yeah, we whizzed through this one. Alright, let's update our GitHub. So git add git commit -m completed part 5 exercise 4. Is that 4? Yep. And then git push u. There we go. Nice, excellent. So that's all done and dusted. Let's give this a refresh. And that's it, we've completed the first part. So next time we're going to be removing repetitive code, looking at overloading methods and constructors. That would be really interesting. So as always, and until next time, good luck and happy coding.